Hola, year 10s. Hello, moles part 2. Right, guys, do you know what? I'm loving this. Everyone's here doing the register. I've got how pink. I need to pause my other computer. There we go. I've got Lynn. I've got Atia. Yeah. Do I have Libby? Any Libby yet? No Libby. She's always late, that Libby. Do I have Audra? I've got Amani. Got Amani. Got Zach. Do I see Zach? Yeah, there he is. Do I have Sophia? Where's Sophia? Got Mel. Yeah, got Mel. Where's Audra and Kayla? Any ideas? Audra's here. Me. Love it. Loving it. Where's Libby? Yeah. The L in Libby stands for late. Ah, there's Kayla. Yo, Kayla. Oh, there we go. Look at that. The last three just rocked up. Minutes late. There we go. I've got a full house. This is amazing. Oh man, do you know what? I just need to give up teaching normally. This is well better for me. Although I can't blow stuff up, that's the only disadvantage. By the way, I'm drinking miso soup out of a chemistry mug. Seeing that? Yeah. Gotta keep up with the chemistry. So how we all doing? There she is, like Full House, like that TV show. Yeah. Helping just put ack. Nice. Wow, very cool. Respect. I know. Can I do? I'm just that cool. Just that cool. So I'm just having a bit more miso. 10 plus respect. I don't know what that means, but that sounds amazing. I'm well up for the noise. Laura, that's all. Noise. I love a bit of noise. Amazing. Well done. Finishing amazing. Wow. I don't know what that means. What does that mean, Amani? Respect the drip. I don't know what that means. It's weird. It's weird, man. Right. Okay, guys, look what I found. Oh my God, I was so proud of this. Look what I found. I found boxing moles. Look at that. Mole sports. That's how tough moles are. It's amazing. I really wish that I'd drawn that. That's just amazing. Yo, Mr. Duncan has a chain. Yeah. What's an e-boy? Like, I've been called this before. What does that even mean? An e-boy. Like an electronic boy. That's weird. I'm definitely not electronic. I wish I was. Wouldn't age. It'd be amazing. Anyway, right. So, guys, let's crack on with our lesson today. So, there we go. This is what we did last lesson. It was amazing. And we were doing our amazing moles. And moles part 2. Yeah. Okay. Right. E-boy is what you are. Of course it is, Atia. Thanks for... I think it has something to do with the electrolysis. Oh, thanks, Mel, for clearing that up. I think it is too, definitely. We can't... No, I know you can't see it helping. I'm just loading it up. I'm like, God, geez, give me a break, will you? Ooh. Right, all right. Let's share this. Let's get this party started. Like that and that. There we go. Hide that. How big did you actually say soz? You guys are so nice. It's really funny. Right, you guys should now be able to see my screen. I'm gonna disable my camera. As I said, I'm trying desperately to keep my laptop from going all shaky all the time. Right. Uh-oh. Oh no. I'm causing loads of trouble. Right, okay. So we should be online now. Winner. So can I ask a quick question? Let's get this bread. I'm so confused. Like, I don't know whether or not it's because I'm old. I feel like it's because I'm old. Did you guys have a chance at doing the mole questions? Kind of hoping you did. I'm going to run through it really quick. I need periodic table. Yes, well done, Tom. Good job, good man. Right. So 90 grams of H2O. Now, can I just... Whoa, okay, that's super fat. So number of moles, grams over rams. I want you guys, if you could do me a favor, could you guys try and write that down as many times as you can? Just whenever you're doing a question, yeah, just grams over rams. Yeah, just write it down. So we've got 90 grams, therefore, 90 grams over the weight of water is 18. 90 over, and yes, I'm using a calculator. 5, I know. 5 moles. There you go. 5, I'm actually going to put moles. Moles or mole, that's okay. Next, 20 grams, number of moles is grams over rams. Therefore, moles is 20 over, what does that weigh? Butane. 12, oh, I'll do this over here. 12 times 4, that's the C4. H10, so that's plus 1 times 10. So 12 times 4 plus 10, 58. So over 58. So 20 over 58, and I get an answer of 0.345. By the way, all answers in chemistry to 3 sig fig. Mr. Duncan, Mr. Duncan, it said that 102 tons is like, yes, that's absolutely correct. What? I think it meant to be tons. Yeah, God, Dominic, I'm super impressed. You Googled that, didn't you? Yeah, just so you know, there is a difference between a ton, T-O-N, and ton, T-O-N-N-E. They're different standards. Honestly, I'm so sorry about that. That is just ridiculous. It's really stupid. Just remember, a ton is 1,000 kilograms. That's all you need to do. Try not to overthink it. But yeah, that's the metric and imperial system coming back to haunt us there. By the way, all answers in chemistry calculations must be given to 3 sig fig. Next, number of moles. I'm not going to write it down because I've done it enough times in my life. Over ammonia, 14 plus 3, 17. 685 divided by 17, and I get an answer of 40.3 moles. Oh, sorry, I shouldn't call it moles. The reason being is that's the Christmas term for moles in chemistry. Next, 102 tons. Right, there's going to be a mark. 102. I need to turn it into grams. That's a nightmare. Yeah, so the first thing I need to realize is that 1 ton is equal to 1,000 kilograms, which is equal to 1,000,000 grams. Holy mackerel. So I'm going to multiply that. I'm just going to add on 6 zeros. Holy mackerel. That's a big number. Over the rams of oxygen, which is 32. So 102, 123 divided by 32. Holy, that's massive. 318. 3 sig fig. 3 sig fig. I wouldn't, so by the way, if I was actually like doing that, I wouldn't do that. I don't like it. If I've got a number that's that big, I kind of want to just give it in full, like at least to the whole number. Like, I just don't like it. Moles. Next, 2 kgs of aluminium oxide. So we've got 2,000 grams over aluminium oxide, which is 27 plus 27 plus 16 plus 16 plus 16. If you do that in your exam, folks, you'll lose the mark. You're not allowed to leave in an unfinished calculation. There is a mark on the exam, yeah, for 102. If you do that, you'll lose all of them. Please don't do it. It's a really bad habit of students to do that. 19.6 moles. I like it. Next, milligrams. That's really tiny. It's 1,000th. 0.0206. 1, 2, 3, 20. Yeah, that's correct. There we go. Grams. So 0.0206 grams over, oh my goodness, I don't even know what the relative atomic mass is of silver. 207? Why do I have 207 in my head? It's 197. So close. So close. 197. 0.0206 divided by 197 gives us 1.05 times 10 to the minus 4. There we go. Next, moles. Easy to forget. Right, now we flipped it over. Yeah, now they're asking for mass. We're going to rearrange. Number of moles is grams over rams. Never learn a rearrangement. Just learn to rearrange it. I need mass. Bring the rams over that side. So rams times by moles gives me grams. Never ever learn a rearrangement. Isn't AU gold? Yes? Oh. Why? What did I put? AU 197. Dominic, wait, 102. What? Huh? What are you talking about? I can't zoom in. Guys, the relative atomic mass of gold is 197. Yeah. Oh, never mind. Nope. Cool. Okay, I'm going to ignore you guys. Right, I've got relative atomic molecular mass of nitrogen is 14 times 2. So that's 28. So I'm going to do 14 times 2 equals 28. There's going to be a mark for 28. And then I'm going to do times by 4. I'm actually going to do it on a separate line. 4 times by 28 gives me 4 times 28 gives me 112 grams of it. Winner. Going to use that equation again. The next one is moles of nitric acid. So I need to work out the relative mass. 1 plus 14 plus 16 times 3. No idea what nitric acid is. Very rarely use that one. 16 times 3. 63. So I'm going to do rams times moles equals grams. So 63 times by 0.1, which is the same as divide by 10, isn't it? Which is going to be 0.6. 6.3. Yeah. Yep. Oh, yeah. Is that right? Yep. I was thinking aluminium oxide. Okay. Oh, no, I think you said silver. Did I say silver? Oh, sorry, my bad. I thought you said silver, that's all. I was thinking, oh, sorry, it's totally my fault. I apologize. And that's moles. No, it's not. It's mass. Oh, it's not. No, forget me. Okay, potassium oxide, which is 39 times by 2 plus 16. 39 times 2 plus 16. 39 times 2 plus 16 gives me 94. So I'm going to go number of moles times by 94 gives me 0.02 times answer. And I get 1.88 grams. Moles of phosphine? Ugh. So, phosphorus, blimey. Below nitrogen in the table. What's the relative atomic mass of phosphorus going to be? Phosphorus is element number, phosphorus sulfur. Element number 31. Oh no. Mass 31. Mass 31? Yes! Winner. 31 plus 1 times 3. There we go. Which isn't very hard, which is 4. So 34. Next, times by 0. No, what's wrong with me? Times by 2.5 equals 34 times by 0 times by 2.5. It's gone mad. Gives me 85 grams. Next, methanol, MR46. I know I'm that nerdy. Sorry. 0.4 times by 46 gives me 0.4 times 46 equals 18.4 grams. Moles of, that's otherwise known as slaked lime. Isn't that called 15? Oh, element number 15. Thank you, helping. Absolutely right. For phosphorus. Slaked lime, don't know what it's at. 40 plus 16 times 2. Yeah, plus 1 times 2 as well. So 40 plus 16 times 2 plus 2. 74? Everyone gets 74 times by 10. 74 times by 10. Gives me 740 grams. Oh, 10 moles is a lot. Cool. Last answer. 0.02 moles of a compound is found to have a mass. Give the relative formula mass. Ooh, much more fun, because I then get to guess who it is. Number of moles is grams over rams. You never remember a rearrangement. I'm looking for rams. Reorganize, bring the rams over. Yeah, that's bod mass in action, by the way. Oh, no, and then divide. Oh, no, sorry. I'm going mad. There we go. Grams over moles. So the grams is 1.64 divided by moles, 0.02. What am I going to get? 1.64 divided by 0.02. I get 82. I have no idea. Wow, that's really interesting. 82. Notice formula mass. That means it's ionic. So it's a metal and a non-metal. I don't recognize 82. 82. Ethane? Can't be. Formula mass. Can't be. Lead? Sophia. What are you doing? Lead's got an atomic mass of 207. The whole thing weighs 82. What you want? Come on. Gone crazy there. Gee. And it's a compound, remember? So it's going to be something like, I don't know, calcium oxide? That's 56. Calcium carbonate is 100. I don't recognize it. I don't know. Sodium carbonate? No, can't be that. Too big. Lithium carbonate? What's lithium? 7 plus 7 plus 12 plus 16 times 3. 74. Duh! I don't know. I don't recognize it. Could there be multiple compounds? Of course there could be, Libby. It's the only thing that I find entertaining is trying to figure out who they are. I don't know who 82 is. I don't recognize it. And I don't know all my relative molecular formula masses, but it's good to take information from the question. So it's a formula mass, which means it must be ionic, which means it must be a metal and a non-metal. I'm just playing around now, folks. Sorry, can't be ethanol. It's covalent, Tiffany. How ping? Sulfurous acid is covalent, not ionic. God, come on, guys. You guys are better than that. These websites are wrong. So you've been looking. Oh, MR's got, what's ethanol? 46. I don't know what I don't know. I could probably find someone eventually. Can I do that? I feel like I want to do it. 84. Calcium's 40. That's useful. I only need 42 left. I don't know. I need 42. 42, lad. 42. 40. Oh, that's so close. No, that wouldn't work either. I just need a non-metal with an MR of 42. The problem is it doesn't exist. It's a nightmare. Well, hang on a minute. If I choose somebody, if I go for a sulfide of 32, I just need a metal. Oh, hang on. Yeah, I just need a metal of 50. Oh, but vanadium's 51. What am I trying to find again? 82. That's really funny. No, I can't do it. I don't know. Forget it. Moving on. Anyway, right, guys. New title today, folks. New title. That was not my best singing. Moles in solution. There you go. That was better. Moles in solution. Woo! So what this is. These are the moles in solution, folks. I don't know what a mole body looks like. I haven't got a clue. I feel like I could make this into a really good image if I wanted to. I feel like I could work really hard at this and go like, it's another hand there, and then we've got a little body, and then he's got another little leg there and another little leg there. I don't know, what does a mole actually look like? Does it have tails? I've got a feeling it got tails. Hey, it's a mole in solution! Oh, it's a mole in solution. Did you get it? He's in a solution. Oh, yeah, his name's Guacamole. Yeah, this is Guacamole. Say hi, Guacamole. So that's a mole in solution. Okay, so now that we've figured out, is it dead? No, of course he's not dead. Moles have their eyes, they're always shut. I mean, oh, God. What's up, Guacamole? Right, he's swimming. He's just swimming around in solution. So we realize that moles is about counting particles. Don't like it. Counting molecules. Yeah, I don't like the fact that it's run over the edge. I'm being really picky now. Counting molecules, right? So, would everyone agree it's probably dead? It's swimming in sodium chlorate. Wow, that's a bit brutal. Dominic, sodium chlorate would be NaClO. The O and the Cl would be the other way around. Have you actually found one? Vanadium phosphide. Right, How Ping, can I have a Roman numeral on there, please? I need a Roman numeral. It's going to be 3 in it to make phosphorus a 1. That's what you're going to do. I was thinking that he wouldn't it be V4P7? What? Laura? What? No. Well, it depends what he's doing. I'm assuming he's going to go for vanadium 3. Yeah. He's built it. He's done well. Vanadium 3 phosphide. Because that means V's a 3+. Phosphide is a 3-. They cancel out. Otherwise known as VUP. Yeah. What has lockdown been doing to you guys? I don't know, Mel. Honestly, they've gone mad. Gone mad. Mad, I tell you. Anyway, so would everyone agree that what we need to do is we need to count the number of particles in a solution? Agreed? So can I ask you now, here's your question. How many moles are in this? There's your question. What's your answer? You can pause the screen and have a go at the answer. Yeah, how many moles are in my solution? Would everyone agree? 1. There is 1 mole in the solution. Agreed? Think 1 dead mole. He's not dead. You guys are upsetting me. Poor Guacamole. There's 1 mole in the solution. Well, hang on a minute. Well, we need to find more information out here, because the question is, what volume of water is in the beaker? So the beaker has markings, and it says 250 centimeters cubed. Now, I need to talk to you guys about volumes. 1 mole in solution. Now we have 1 mole in 250 centimeters cubed. I've now given it a volume. Now, what I need to do in this lesson with moles in solution, we need to talk about volume. We need to talk about moles. And we need to talk about concentration. Because unfortunately, now that we've got a liquid, we now need to actually have all of these things broken down because we're going to need them all. So the first thing I'm going to do is let's talk about volume. I'm moving guacamole out the way. Can you put a little subtitle, please, folks, of volume? So first of all, I want to explain that the biologists use a different unit than I do. Yeah, the squishy biologists, so in bio, they use the milliliter, ml. They use the milliliter. Yeah. Now, the great thing is that the chemists weren't stupid. And what they said was the chemists went, oh, well, do you know what? 1 milliliter is the same as a real unit of measure. So yes, the biologists just make stuff up when they want it. So the milliliter is the same as a centimeter cubed. These guys here are the same. So if I now have 25 milliliters, that is equal to 25 centimeters cubed. Is everyone okay with this concept? That is a fat chin. It's a fat face, that. There we go. So I think everyone's okay with this concept. Yeah, thanks, Dom. Great job. So the next thing is, well, what's the bigger unit of measure? So if we go bigger, does anyone know what the bigger version of the milliliter is? I bet everyone does. It's called the liter. Yeah. So the liter unit then needed to be converted to a real unit. No, not a megaliter. It's just a liter. Are you wondering what's bigger than a liter, Dom? Oh my goodness. You guys have honestly lost the plot, I tell you. The next one up is called a I don't know what the next size up is for biology. They don't ever tend to talk about it. It probably would be a megaliter. No, it'd be a kiloliter. It'd be a kiloliter, not a mega. Kilo. And the real, well, I went supersonic there. The real unit for a liter is a decimeter cubed. A Diem cubed. I'm going to write that underneath it. Decimeter cubed. Is everyone okay with that? It's the real unit. Okay, so now that we've talked about volumes, what we now need to do is talk about concentration. So, concentration. You guys have done this in bio and in chemistry. Can someone tell me what they think concentration is? A decaliter is 10 liters. Yeah. Kiloliter, kilo lad. What does concentration mean, folks? Pause the video, write down your answers. Moles per day, absolutely. Concentration is the number. I feel like my writing's too thin. My screen's gone all shaky, by the way. No, I'm going to do it proper. Number of particles. No. Number of molecules. Number of molecules per volume. What does that look like? Three moles per volume. Eight moles per volume. So you realize the per volume doesn't really help me very much. We need to decide on a volume. So since we always use the word moles, because this is counting, yeah, number of moles per volume, we need to choose a volume. So just like Lara's already picked up on it, which one are we going to choose? And the chemists decided to choose the liter. They said that a centimeter was too small to measure properly, so they're going to go for the liter. So we now have concentration concentration units. This is the main one. Number 1, moles per liter. That's the very first one, folks. Oh, not to the minus. I'm sorry. I'm mixing up GCSE and A-level together. Yeah, moles per liter. Now that slash, I'm going to come back to. We say it means per, but it doesn't actually mean that. It actually means divided by. I always like that. Next, there is a second unit for concentration in chemistry. Number 2, there is grams per liter. Grams per Diem cubed. 2 units that they love to ask about. Okay, so whenever we're talking about moles in solution, we've got a whole series of things that we need to know about. If you were given an unknown, a beaker of water that they say it is seawater, and they said concentration, concentration of sodium chloride, which will be, of course, the salt that's in it. What would I need to know about this guy? I need to know 2 things. I need to know, number 1, I need to know its volume in liters. Agreed? Next, I need to know the mass of salt. The mass of salt in grams. Now, students at this point usually go, well, hang on a minute. Doesn't it depend on what units they're asking for? And the answer is no. We know that concentration comes in 2 formats. Moles per liter and grams per liter per Diem cubed. Well, the great thing is, once you get to here, you can get to here. So these 2 go hand in hand because the practicals mean that you have to do this. So question number 1, how do you determine its volume? This is not difficult. Using a measuring cylinder. How do you determine how much salt is in it? So this one, practical, easy. Use measuring cylinder. Right, the second one's much more challenging. How do I find out how much salt is in it? Right, guys, pause the video, and I just want a process name that you could use to find that out, please. The answer is evaporation. It's not actually, it's actually crystallization for Edexcel. Crystallization. Stroke evaporation, because they're the same thing. We're going to evaporate all the water, and then we're going to weigh the salt that's left behind. That's how we're going to do this. Now, at the end of all of this discussion, at this point, students always say to me at this point, this is usually the point where they suddenly go, do you know what? I'm kind of lost at this point. And I go, no problem. Let's make this easier. Let's turn this into an equation. So we've already seen grams over rams. You have a new one. Number of moles is C times by V over 1,000. Now let me explain this. That is actually not the original equation. The original equation is C times V. But this equation here relies on 2 bits of information. If you are going to find the moles, the concentration must be given in moles per dm cubed, and the volume would have to be given in dm cubed as well. But that's very unlikely. Chemists don't weigh out or measure out volumes in liters. That is crazy. We deal with the centimeter cubed scale. And if you're in centimeters, if I measure out 10 centimeters cubed of solution, what's that in decimeters? You just divide it by 1,000 to get 0.01 dm. So I put it into the equation because that's the one you're going to use 95% of the time. And it saves that. Honestly, it's just easier. I swear it is. It's actually a really good equation to know. Yeah. But as I said, every now and again, they might throw in a dm, but it's very rare. And you just get rid of the 1,000. If they threw in a meters cubed, then you times it by 1,000. Not that you need that one. So we now have a new equation. Do you now see why I hate triangles? This is not, I know that students go, oh, but I can use a triangle for this one, so I'm going to use that. And I'm like, oh, don't do it. Just please don't do triangles. I hate triangles. Just learn to rearrange. It's better maths anyway. And you guys are good at maths. Madness. Okay, so let's now start having a look at some of these questions for moles in solution. Okay, so moles in solution questions. Okay, number one. Let's keep it easy, start off. I'm going to tell you that I'm going to put 0.5 moles of salt into 100 centimeters cubed of water. What is my concentration? Pause the video. Have a go, please. Don't forget to give your units at the end. Right. Number of moles is C times V over 1,000. Why am I over 1,000? I'm in centimeters cubed. Yeah, so that's going to need to be there. Cool. Next, I'm after concentration. Need to reorganize. Bring 1,000 up. 1,000 times moles equals C times V. I want concentration, bring V down. There we go. Okay, now input my data. Therefore, 1,000 times by 0.5 all over a volume of 100 equals. Now, I'm going to do it properly on my calculator and then but in reality, you guys probably realize that I don't need to. The answer is 5. The reason being is the 100 cancels out with those, so it's just like 0.5 times 10. It's the same thing, but it depends on how good your maths is. Yeah, I prefer just using a calculator. You never do anything in your head. This is 5 moles per dm cubed. Is everyone okay with that? Question number 2. Question number 2. Question number 2. So I'm going to give you solution X contains 250 centimeters cubed of 1.3 moles per dm cubed sodium sulfate. Right? How many moles is it? Moles? Question mark. This one's easy. I've got a vol. Pause the video if you want to have a go at it. There's my volume. Here's my concentration. Number of moles is C times V over 1,000. Input my data. Number of moles equals 1.3 times by a volume all over 1,000. And I get an answer of 1.3 times 250 divided by 1,000. Gives me 0.325 moles. This is not overly complicated, folks. It really, really isn't. It's just using this equation to be able to get to your answers. Dead straightforward. That actually brings me to the end of my lesson, which is really nice. We're a couple of minutes early, and I'm really pleased with this. Oh, no, I'm going to do one more. Question number 4. Is this 3 or 4? Number 3. Question number 3. Let's make this harder. So I've got 250 centimeters cubed of sodium chloride with a concentration of 2 grams per liter, 2 grams per Diem cubed. Concentration in moles per Diem cubed? Question mark? And mass of NaCl total, please. Much, much harder. Isn't question 2 3.0? Have I made a mistake? 1.3. Maybe I typed it on a calculator wrong. It's totally possible. 0.325. Have you typed? How Ping? Check your calculator, please. 1.3 times 250 divided by 1,000. 0.325. How Ping? Just check me. Please check me. Yeah, I'm definitely right, Halping. Definitely right. What? What? Guys, 250 over 1,000 is the same as 1 over 4. Timesing it by a fraction. Did you guys not see the point? Sorry. There you go. Thank you. That's what the problem will be. It's all right, not 13. Thank you. That one's much harder, folks. Can I just point out, it isn't. You just need to remember grams over rams. Yeah? So number 1, concentration in moles per Diem cubed from grams. Would everyone agree that the decimeters hasn't changed? So I just need to actually get from grams to moles. So I'm going to do number of moles as grams over rams. 2 grams over MR of that, which is 23 plus 35.5, which is 58.5, gives me 2 over 58.5, gives me 0.0342 moles per Diem cubed. I'm just putting the Diem cubed back. Oh, I'm sorry, folks. I keep doing the A-level bit. Sorry, there you go. So I've just divided it by the MR because the Diem hasn't changed. I'm just going from grams to moles. So what's my total mass? That's actually easier. Yeah? My total mass is going to be, so I've got 2 grams per liter and I've got 1/4 of a liter. So I've got 0.5 of a gram. Would you agree? It said I've got 2 grams in 1 liter and I have 0.250 of a liter. I've got 1/4 of it. Divide by 4. So divide that number by 4 and I get 0.5 grams. I know it's harder. Never mind, I thought it was 13. It's my fault. Yeah, it's okay. Right. Guys, I'm going to post onto the classroom. I've already got the worksheet all lined up, I think. Oh, I've lost my... There we go. There you go. I will post this worksheet onto the classroom, folks, along with the mark scheme. Please have a go at it. It's dead easy. It's just practicing what we've done today. And that actually brings us... Look at that. We've only got 5 minutes left. It's amazing. I've got to turn my camera back on, enable device, then go back to my SteamYard, go start camera, stop sharing, bring back, way back, back. How do you know when to use which of the 2 units? When the words moles or grams appears, Mel. It's really obvious. You'll see in the question. I promise you, don't overthink it. You don't need to. Yeah, just follow the routine. It's very straightforward. Backstreet's back, all right. Nice, Lara. Nice. I'm so tempted to sing it then. Right, guys, I'm going to love you and leave you. I hope you have a nice rest of your day. Take care of yourselves, and I will see you very soon. All right, guys. See you Monday.